Hey guys. Okay, I'm back and we are going to talk about distributive property today. So let's look at our Weevil statement. This is our learning standard, what we should be able to do by the end of today. Okay, so it says we will solve linear equations in one variable, including those for which the application of the distributive property is necessary and for which variables are included on both sides. So when we talk about our we will statement, I want you to think, okay, what are they wanting us to learn? What are they trying to get us to do? So let's look at our verb. What's our verb? We will do what? We will solve. Okay. All right. So we will solve what? Linear equations. So let's circle that. Okay. And one variable. So let's think back. Variable. What is a variable? All that is a letter that represents a number. Okay. And then they're wanting us to use a couple different things. They want us to use distributive property. Okay. And we're going to have variables on both sides. So we're going to have an equal sign, and then we'll have letters and numbers on both sides. Okay. So we're going to solve linear equations and we're going to do distributive property. So today, distributive property is what we're going to focus on. Okay. Now I have your anchor chart, so make sure that you have yours as well. And let's look at a couple different things. So when we talk about the definition of distributive property, there's a verbal definition and then there's an algebraic or math definition. Okay, so a verbal definition, we just want to define it as a math process that involves two different operations. Okay, so that's going to mean we are going to multiply and add, let's say or subtract. Okay, so those are our two different operations. Okay, we're going to first multiply and we have addition or subtraction in between. Okay, so let's look at what that looks like. Now, algebraic just means numbers and letters. Algebraic, fancy word. You can go home or tell your parents, oh yeah, I did algebraic expressions today, and they'll think you're really fancy. Okay, so algebraic might look something like this. Okay, so I have A parentheses B plus C. That's an algebraic expression. Okay, now as soon as I see those parentheses, I have to think that tells me to distribute. All right, when something's side by side in math, that tells us to do what operation? Multiplication. Okay, so if I think about that, then I have A times B, which gives me AB, because I don't know what A is and I don't know what B is, but I really don't care. I just understand that, hey, now I'm distributing them and they're going to become side by side, or I'm going to multiply them. Okay. Now I've got that plus C. So I have to take care of that too. So I have to think A times a positive C. Again, I really don't care what they are or what they represent. I just need to understand that I'm multiplying them together. Okay. So these two things right here are equal to each other. We just simplified it. We wrote it in a different way. Okay. You can think of another algebraic expression like this. So I've got x. This time I'm going to use y minus z. And I have to think, okay, x, I've got parentheses. So parentheses tell us to distribute or multiply. And I have to take care of what's inside the parentheses. Okay, so I've got x times y. Again, I don't really care what they are. I just need to understand that I'm multiplying them together. So now I have x and y together. And then I've got x times a negative z, which would give me a negative x z. So here in the verbal description, we talked about involving two different operations, multiplication and addition or subtraction. Okay, so in the first example on our right, we have multiplication because we have our parentheses, and then we have addition because of that plus sign in the parentheses. Okay, so there were our two operations. All right, in the second example, you have multiplication because you have those parentheses. All right, and then you have subtraction because of that subtraction sign inside the parentheses. Okay, and again, those two expressions are equal to each other. Okay. Now let's make a visual representation of what we're talking about here. Okay, so when I talk about a visual representation, I just want to represent it with like a picture. Okay, it doesn't have to be fancy, but I want to prove that this right here is equal to what's on the right side, just like what we talked about earlier. Okay, so this first one, I have 2 parentheses x plus 3. Okay, so let's represent that with a picture. Let's use blue. Okay, so I have 2 parentheses x plus 3. Okay, now I can think of this a couple different ways. Okay, now in that parentheses, I have x plus 3. Okay, so that's one group that I'm going to have 2 of. Okay, so let's represent this right here first. Okay, so how many x's do I have? Hopefully you said 1 because there's an understood 1 there. Okay, so I have 1x. There's my x. Okay, and then how many 3's do I have? Or think of it plus 3. Okay, so I could represent it actually like this. So I've got 1, 2, and 3. Okay, so that is my first group. So I could even put it in parentheses. Okay, but how many of those groups do I have? Well, I have 2, right? So I need to make another group that looks exactly like that. So I've got x plus 3. Okay, and so there are my 2 groups of x plus 3. Done. Okay, now we want to prove or show that it equals 2x plus 2 times 3, or 2 parentheses 3. Okay, so let's do our 2x first. Let's do it in red. Okay, so how many x's do I have this time? I have 2. Okay, so I've got 2 x's. Okay, now I have plus 2 groups of 3. Okay, so let's do that in, we can do it in blue. Okay, so I've got my first group. Okay, then I've got my second group of 3. So I have 2 x's plus 2 groups of 3. Now, if I want to see if this is the same, well, that's really easy because I can just think, okay, so over here, how many x's do I have? Well, I have 2. How many do I have over here? 2. Okay. How many pluses do I have? Well, on the left side, I have 6. So come over here, I have 1, 2, 3, 4, 5, 6. So I have 6 on the other side. So those are equal, and that is why distributive property works. Okay? So maybe that made things clearer. But let's actually do some problems now. Okay. Oops, I'm drawing all over it. Okay, first example. Sorry if it's kind of hard to read. Okay, so I have 6 parentheses a plus 9. Now, as soon as I see those parentheses, I have to remember that parentheses tell me to do what operation? Multiply. Okay, so I'm going to take this 6 and I'm going to distribute it or give it to everybody in the parentheses. Okay, so I have 6 times a. Do I know what a is? No, but again, it doesn't really matter because I have 6a. Okay, I made them side by side. Okay, now I have to distribute that 6 to the plus 9. I do know what 9 is. 6 times 9 gives me 54. So that was this right here. And then I'm done. Okay, so this is the same thing as what we just started with. Okay, just a different way to write it, just like up here. Okay, these are equal to each other. Okay, we just simplified it. All right. Okay, let's look at B. Okay, now on B, they wrote it a little differently. They put the -3 at the end. Okay, but it doesn't matter because I see those parentheses, and parentheses always tell me to multiply. Okay, so I have this -3, and I'm going to distribute it to everything in the parentheses. So -3 times a j just gives me -3j. Okay, then I've got a -3 times a -7. This is when I would put it into your calculator. If you know your integer rules, yay, go you. But signs are really easy to mess up on, so I would think -3 times a -7, which would give me a positive 21. And then there's my answer. Okay, those two expressions are the exact same. All right, letter C. Okay, again, sorry if it's hard to see, but this is a -5, and we're going to distribute it to 2w. Okay, so I don't know what the w is, but I do know what the 2 and the -5 are, so those are what I'm going to multiply. I've got -5 times 2, which gives me -10, and then w has to stay with it because I don't know what it is. They're just going to go side by side. Okay, again, I'm going to distribute to everybody or everything in the parentheses, and I've got a -5 times a positive 7. Again, put it in your calculator. No need to remember your integer rules. And then we stop. There's our answer. Okay, all right, last one. Okay, now this right here is a decimal. Okay, but it doesn't matter. I can distribute a fraction, I can distribute a negative, I can distribute decimals. Okay, it's still the same. You're still doing the same thing. So I've got 0.5 times 8m. So I would punch that into my calculator. 0.5 times 8, which gives me a 4. And then I keep the variable with it. And then, 0.5 times a -6. Again, put that in your calculator and you would get a -3. And you can stop. Okay, so hopefully this helped you understand distributive property. It's really easy. It's the first thing that we do because we have to follow order of operations. PEMDAS, parentheses, tell us that that goes first. And we always want to remember that parentheses tell us to multiply every time. Okay, y'all have a good day.